Hello, Mishler math students, geometry students in particular. Nice to see you. Wait, I can't see you. You can't see me. We're going to talk about transformations. And because some of you seem to be a little bit confused, so transformations in the coordinate plane. That's what this thing over here on the left is. That's a coordinate plane. And we're going to talk about transforming things in the coordinate plane. First, I'm going to put something onto this coordinate plane. I'm going to create a point here, point A, point B, and point C. And I'm going to do my best to connect these 3 points with straight lines. And so we have a triangle. Now this one didn't quite work out perfectly. Like I like them perfect, but it didn't quite work out perfectly. But that's okay. We're going to probably try to live with that now. So let's look at the coordinates for this point, point A. If you count back on the x-axis, you go -1, -2, -3, -4, -5, 6. This is -7, comma, and it's 1 above the x-axis. So if you line it up on the y-axis here, it's 1. Okay, so -7, 1. These are the coordinates. Point B, 1, 2, 3, 4. 1, 2, 3, 4, 5. So I've got -4, comma, and 5, positive 5, because it's above the x-axis. This is plus y, this is negative y, this is plus x, this is negative x, okay? And then C is -1, -2, -3, positive 1, positive 2. So -3, comma, positive 2. So those are our coordinates for those 3 points. Now I'm going to list those 3 points. A is -7, 1. B is -4, 5, and C is -3, 2. So I'm going to show you how to make 3 different transformations using those 3 points, those 3 vertices of this triangle. The first one is going to be a translation. Another way of referring to this is slide. It means slide because we're just going to slide it this way or this way. And so I'm going to make a transfer, and I'm going to describe the transformation this way. Okay? X and Y is going to become X plus 4. That's a 4. Okay? And Y minus 2. So that's what's going to happen here. X and Y is going to change into X plus 4 and Y minus 2. And what does that all mean? Well, let's look at point A. Okay? Point A is -7 and 1. X is -7, Y is 1. I'm going to change this to X plus 4. Well, what's a -7 plus 4? That's a -3. And Y minus 2, and this is supposed to be a 2, not a Z. So Y minus 2, Y is 1. What's 1 minus 2? That's a -1. Okay? So my new point, point A prime, okay, is going to be -3, -1. So I look at 1, 2, 3, -3, -1. So there's A prime. Okay? Let me make that a little bit better looking so you can see it a little bit better. Can you see that a little bit better? Thank you. Good. I'm glad. Thank you for the response. Okay. So there's A prime. Now, let's look at the next one. B. The original point B is -4, comma, 5. So I'm changing that to -4 plus 4. So what's the new X going to be? It's going to be 0. What's 5 minus 2? Because the old Y is 5. The new Y is -2. 5 minus 2 is 3. So at 0, 3, 0, 1, 2, 3. There's my new point, and that's B prime, B prime, and so there's my point B prime right there. And then finally, let's do the same thing with C. C is negative 3, comma 2, and that's moving to, well, let's see, negative 3 plus 4 is positive 1. And 2 minus 2 is 0. And so that's C prime. So let's put C prime on the coordinate plane here. 1, comma 0. Because 1 is my x coordinate, okay, and 0 is my y coordinate. So that's C prime. So let's see what happens when I connect these points. And then, oops, sorry about that. There's a nice neat straight line there, sorta. And see if I can do the same thing here. Now, take a look at the red triangle, compare that to the green triangle here. And what do you see? Hopefully you will see the same thing I see, which is we went to the right 4 units plus 4, to the right 4 units, okay? From here to here we went plus 4. Sorry, I'm not good with numbers, ha 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 ha. And then we went down 2 units. From here to here we went down 2 units. So we took B and we went 1, 2, 3, 4, 1, 2. We took C and we went 1, 2, 3, 4, 1, 2. And we took A and we went 1, 2, 3, 4, and 1, 2. You see, each one of these points was taken 4 units to the right and 2 units down. And that's what we have here, 4 units to the right and 2 units down. So that's how we transform any kind of figure on the coordinate plane. We simply move it according to these instructions right here. And so that's what a translation is all about. So let's try another transformation. And I'm going to clear this out. And we're going to try another transformation. And this time we're going to do a reflection. And I'm going to start with another red triangle. And this time I'm going to, A is right here, and B is right here, and C is right here. Now, A, what are the coordinates? 1, 2, 1, 2, 3, 4, 5, 6, 7. Oops, that's 3 and 7. Sorry about that. 3, comma 7. B, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So B is 7, comma 5. Notice these are all positive because I'm in the first quadrant. X and Y are both going to be positive in the first quadrant. And then C is 1, 2, 3, 4, 1, 2, 3. So this is 4, comma 3. And so I'm going to connect those dots so you can see we have a nice pretty triangle here. And then finally, that might be the, except for that little squiggle at the end, that might be the best triangle I've made yet. Hang in there. You won't believe how pretty these triangles are going to get pretty soon. Okay, so we're going to do a reflection. And this time, watch how I write this. I'm going to go X, comma, Y is going to change into negative X, comma, Y. You say, well, what is that all about? What does that mean? Notice that the X changes to a negative X. That means that I'm going to reflect across the Y-axis right here. And let me show you how that works out. Okay? Where was I? These are the colors I'm working with. Okay. So point A is 3, 7. B is 7, 5. And C is 4, 3. And so I'm going to reflect each one of these according to what I see here. Look at what it tells me to do. It says for every x, make it a negative x. So x is 3, make it a negative 3. Y stays the same. You just say y is exactly the same thing. If it was 7 here, it's 7 over here. X is 7, so x becomes negative 7. And y stays the same. X is 4, x becomes negative 4. And, oops, sorry about that. I actually have an eraser on this thing. Isn't that amazing? So negative 4 and 3, because y stays the same. So these are my A prime, B prime, and C prime. This is the transformed image. This is my image over here. This is my image. And this was my pre-image. Anytime we do transformations, you got a pre-image and an image. Okay? So let's just do some plot these points and see what we have. Negative 3, 7. 1, 2, 3. Negative 3. 1, 2, 3, 4, 5, 6, 7. And there we have A prime. And negative 7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Negative 7 and 5. And that's B prime. And then C prime, negative 4, 3. 1, 2, 3, 4. 1, 2, 3. Negative 4, 3. And that's C prime. Now, let's connect the dots and see what we end up with here. And now, do you see the reflected image here? I want to point out something very important here. See, this point lines up with A, and A prime line up with each other because I'm reflected. It's just like I take this, and you see, this is my line of reflection. The y-axis is my line of reflection. You see, I'm the same distance here as I am here. Same thing with C. Same distance here, same distance here, and of course the same with B. And you notice that the y-coordinate is the same, 5, and B prime is negative 7, 5. A prime is negative 3, 7, and this is 3, 7. And C prime is negative 4, 3, and this one C is 4, 3, so negative 4, 3. So that's how you do a reflection. And then finally, we're going to do a rotation. And a rotation, and hold on a minute, let's see, edit, clear, and a rotation. Okay, we're going to make it real easy here. We're going to use the origin, 0, 0. It's the center of rotation. So, and let me create a quick, another triangle here. Oops. And like I keep telling you guys, this is not as easy as I make it look. Okay, so there's a nice pretty triangle there, and I've got point A here, point B here, and point C here. If that's hard to see, if you got a lot of sunshine shining on your computer screen or something, you might want to get into it indoors so you can see a little bit better. But this is we're gonna do a rotation, and the rotations are real easy. You're just gonna make 90 degrees, and a 90-degree rotation looks like this. X and Y become negative X and negative Y. So, what does that all mean? Well, see, 1, 2, 3, A, B, C. A is 1, 2, 3, 1, 2, 3, 4, 5, 6. So 3, comma, 6. What is that going to become? That's going to become negative 3, comma, negative 6, and that'll be my A prime. B is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 7 and 8, that's going to become negative 7 and negative 8. That's B prime. And then finally, C is 1, 2, 3, 4, 5, 1, 2, 3. So 5, comma, 3 is going to become, make a better arrow there, negative 5, comma, negative 3. And that's C prime. So, let me change colors here and make that a little bit easier to see. We're going to rotate this 180 degrees. So let's see what we end up with. Negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. Negative 3, negative 6, and that is A prime. And then we have negative 7, negative 8. 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8. And that is B prime. And then negative 5, negative 3, 1, 2, 3, 4, 5, 1, 2, 3. That point right there is C prime. And when I connect those dots, I have the exact same triangle. Ew! Alright, let's try this again. I have this exact same triangle. A has changed into A prime. Now, if I were to go this way, 180 degrees, it'd be the same thing. That's how you do transformations on the coordinate plane. Thank you for listening.